This is Scott. I'm back with another short video. You can see what we're about to look at here. This is just a playfield and it's playing the Mr. Do music. Let me unpause it here so you can hear it. And this was pretty much the first, beyond the music, this is the first thing that got output, which was a working MSX ROM with just the gameplay area here. And I do want to walk you through some of the things that came out of the first session, where I was like pulling the music, and well, I can show you, but I was pulling the music out of the arcade binaries to put into a ColecoVision game. And let me pull that up for you real quick. So that's how this all started, with a ColecoVision ROM hack that I had been working on for quite a long time. And let me open that file really quick. So we have, sorry, give me 1 second, I'm gonna pull it up. So we have a ColecoVision game that we had been working on for a couple years, and the music was created by recording the audio of, and I'll play it really quick here so you can hear it. The audio was, then this is now the arcade music, but when it started 2 years ago, I had basically transcribed the music from the arcade game by getting a WAV file of audio, converting that into MIDI, bringing it into Logic Pro, separating it out by track, and then transcribing each note, note for note, as hex code to put into the assembly file. So note by note, I built those songs over the course of, I would say, about a month or two. And it's a handful of songs, because when you get the extra award, that plays the song from Astro Boy, and when you get the diamond, that plays the Twinkle Twinkle Little Star song. So those all needed to be created, and some of those are harder than others. So when Claude Opus was announced, I thought, I wonder, could we get the actual arcade music out of the arcade game? Could I somehow reverse engineer the arcade game, and what would that take? How could I get the audio out of there and put it into our ColecoVision game? So that led me to this application called Ghidra, and I opened the binary in it, and there's some buttons in here that will, and I asked Claude, like, walk me through, how do I use this application? And right away it started to do the disassembly. It started to turn the bytecode, which is just raw data, into instructions like this. So it's actually code, and the difference between code and data is different, but a song has looks the same as logic, so it's hard to really figure out what's what as a human looking at it. Now, there are humans that are good at this. I'm not one of them. And after Ghidra had done its thing and ran the algorithms and figured out what was a function, what was data, I said, well, now how do I find the music in here? And that was going to be hard. And I realized, or I soon found, there was an MCP server that allows an LLM to directly access functions inside of this application. And I hooked that MCP server up. I said to Claude, I want the music out of this arcade game. Can you locate it? The game is Mr. Do, and I explained what the game was about and how, what modes were going to trigger these sounds. Well, unfortunately, that required understanding a lot more about the game before it could find where the songs were. So I just kind of let it let at it. I gave it all the rule set of the game. I gave it the Wikipedia entry. I explained what, how the game works, and the LM has some fairly decent working knowledge of the game. So ultimately, that we wound up with a really decent disassembly of the game, and I started getting the audio that I wanted out of it. I wanted the coin sound effect, and once I got that, I was like, oh my gosh, it's all in here. We could just pull it out, and it was all able to be translated into this ColecoVision sound format. So we wound up getting all the music out of the arcade game, and a couple days later, I'm thinking, well, we got that, like, and I could have gotten a lot more than just the music. The graphics are in here, all the game logic, and I thought, well, wouldn't it be cool to have this on a home console? Which, there are a couple really good ports of Mr. Do for home consoles, but nothing that's quite as close to the arcade as I would like. There is one on the DS that's really, really, really close. You have to hold your DS sideways to play it. It's really hard to play. The other one is for the Super NES, and that is a really faithful port of Mr. Do. Um, but I wanted to maybe get this onto another console. So I thought, well, what ones could we do? And I brought it up in the Atari Age forum, and the Sega Master System kind of stuck out because it has a lot in common with the ColecoVision, and I could just take all we've learned from this ColecoVision version and kind of bake it into the Sega version, the Master System version. So that's where I started, and I wound up getting this, which is I said, could you take the music and make a Sega ROM out of this? So it made a Sega Master System assembly file. I compiled it in Windows here. You can see my running instance of Windows where I'm using this compiler called TNIASM. And it made this. So I have, and you can't hear this, but basically it's the music from Mr. Do. I can crank it up here and maybe you can hear it over the microphone. So that would run if I put that onto a Sega Master System and plugged it into the console. You would hear that music. Now it's not the game; it's just the music. But that was this hopeful glimmer of, could we get the whole game onto the Sega Master System? So I started chatting it out with some of the other people in the Atari Age forum, and somebody who I worked very closely with on this ColecoVision port said, why don't you look at the MSX? It's got all these great features that would enable very few concessions to have to be made. You could port this game practically one to one. It would even fit vertically. And when we looked at the Sega Master System, the game would not fit in the vertical resolution of the Sega Master System. It only has 192 pixels. We would be about, I think, 32 pixels short. We would be 2 rows short of an entire playfield. And resizing the pixels is not something I was not gonna go down that road. So we wound up with, oh, well, maybe we could port it to the MSX. So just thinking, the bare minimum, could it draw the play area? And that's how we wound up with this, which is the whoops, I have to change over. Let me change over quickly to the cancel this. I have to change over to the other the machine. So these machines have so much in common that they live all inside the same emulator here. So the ColecoVision and the MSX live inside this open MSX emulator. So now if I load, whoops, cancel that. Now I'm going to load up the first piece that we got out of Claude, which was just the gameplay area. And after that, things just started to happen. And I want to show you some of the things that just surprised me and kind of made my jaw drop. I was just in disbelief. So you can see I even named the project folder Do Disassemble, because I was like, let's just disassemble this game and see how far I can take it. And maybe in a few years we can revisit it and have this disassembly and give it to an LLM, and maybe it could do something. Like put it on. My harebrained idea would be like make a Nintendo game out of an NES game out of it. So then we wound up with, let's go, oops, I'm sorry, I'm jumping out of the wrong folder here. So then we wound up with this draw test cart, which was just the level. Just the level. It just drew the level. And that came only after I said, what's in here? What do you see? I was asking the LM, like, do you see any graphics? It's like, oh yeah, I think I see some sprites. And it started writing Python scripts. And you can see there are artifacts in here, called it tools, and it started spitting out like these Python files. And if you run those files in Python, like if I literally run this on the command line, it will start and feed it the arcade binaries. It will spit out these images, and this was super exciting. I was like, oh my gosh, it found the sprites. And it even had the right colors. My jaw dropped. I was like, I can't believe this is in here, and I can't believe it can figure out how to put this all together. And I got this out of it. I got this out of it. Then cherries and tiles and the apples, and it just started flowing. Score fragments, the ball, the tile set, the colors for the levels, all the dessert items that you can collect. And this is something got scrambled here, but you can see what it is. You can see what's happening, and it's slow, and you can see the iteration like over the course of from 1:44 in the afternoon on July 6th, and then finally like at 2:08 in 20 minutes we went from this and this to pretty much exactly what these things look like in the game. So then I was just really confident that, wow, if it could figure out the game logic, if it can find these, if it can figure out the game logic, it already did the disassembly, so it knew where the desserts was, it knew where the sprites were, it knew where everything was, and it just started spitting these artifacts out, and it was just exciting to see it all come out. And it started getting the artwork and then it started like building. See, this is 3 days later. As I was at this point, we were now full swing into building the game out, and I'll show you. As I'm gonna load up another version. It also had done this video test. Let's see what this is. And I can step back through the history, and you can see kind of this was the second thing it output, which was, oh, I'll just put up a HUD, like a placeholder to show where the scores could be, and this is just text. It doesn't do anything, and there's nothing to do in here. But it was a sign that yes, this could happen if it can draw to the screen, and it can get a player character walking around. Then I was feeling pretty confident that if we took it really slowly, step by step, implementing the game as it would be if you coded it by hand, you could get a game out the other side. Now, would the LLM possibly just break the game? And you can see this was the next thing that it did, which is take the sprite, put the walk cycle, which is, it only used 2 frames of the walk cycle, and that was a point that I brought up. I was like, well, there's 3 frames in the walk cycle, we're gonna need that 3rd frame. And yeah, then we had a character movie on the screen. So I want to just make super clear the process of taking the arcade game and turning it into a port was all of these baby steps. And I'm going to tell you, the baby steps just happened so fast. So it was baby step after baby step after baby step, and each baby step was just a prompt. And almost, I would say 90% of the time, on the other end of the after the output was done, and I got a build from the LM. I'm going to tell you, it worked. It implemented it. So then we had, from here, we went to, can Mr. Do walk in the rows and dig? And then we went to, can Mr. Do collect cherries? And then we went to, can we display? And things that you would think we would bring out first came much later. Adding the apples was later. Adding the enemies came later. Really, after this, I think we went into making the round start properly, and putting some of the HUD up to kind of just break the work down and get the core functionality running before we started doing, like, oh, put all the enemies, we're not going to go from here to put the enemies on the screen and make, enable their AI behavior. Mr. Do couldn't even dig in the tunnels, and that means the enemies couldn't dig in the tunnels either. What would we really have? So next came the movement of Mr. Do, and could we get him moving properly through the game. So yeah, that's kind of how it all came together. And some of these artifacts here, I'll show you some of the rest of them as it grew. These artifacts came from Python scripts. It was just the LM reading what was in the ROM, reading the disassembly, understanding this is the very good screen and how it's created, and then it would start spitting out graphics. And from there, it would then implement those into in assembly into the file for display in the game itself. And here's the wonderful screen. Here's the clown screen, and the extra screen, and more tile sets. This is the all of the font, and this was when I'm debugging how Mr. Do is facing. And here I'm going to confess, the current version of the port, Mr. Do does not face in the correct direction as he's moving. But to my eye, it's correct. So is it arcade accurate? No. But when I watch the arcade, it's actually a little funky. When you're moving right and you go up, I think Mr. Do's head should be on the left, and vice versa. As he's moving left, when he moves up, his head should be on the right, so that it looks like he's turning corners and keeping his same orientation. But the arcade doesn't do that, and I think that's for simplicity's sake, because otherwise he's mirrored two different ways as he's going down, and he's mirrored two different ways going up. And in the arcade, he only has one orientation when he's moving up and down, which is which was a surprise to me, because when I started playtesting the game and saying, no, I think you got this wrong. I think you have it wrong. And so I corrected it to the point of literally rewriting how Mr. Do should face as he walks through the play field. So I'm going to load the latest version of the game so you can see what the latest progress is as I talk here. So now you'll see we have an attract mode without a Mr. Do logo. At the top of the screen, you'll see a Mr. Do logo on the arcade. Right now, in the current state of the ROM, the instruction mode plays out, and you can see how the game is played through this one little screen here, where Mr. Do is collecting all of the letters in the word extra, and you'll see on the right side they're lighting up in yellow as he collects those letters. And finally, he will squash the A and get an extra life, and then down there he collects the diamond and gets a credit. So that's the instructions that are in the arcade. And that was a huge challenge, because the entire game needed to be pretty much done for that screen to even remotely work, because that screen is an entire is the entire game is in that one screen, believe it or not. So, and to the point where uh, in an early iteration of this implementation for the MSX, after Mr. Do collected the diamond, it would start a round. It would start the second round, and Mr. Do would relocate himself to the bottom middle of the screen, and it would start playing the beginning of the round tune. And that's clearly not supposed to happen in this attract mode. So that that was something that I had to work very hard on. That, again, LLM assistance aside, all of this, all of these steps, all of the baby steps that were required to create a game from start to finish had to be followed. It wasn't like, okay, now do the entire port, and it's like, now draw the owl. That's not how this came together at all. It's the most the smallest baby step you can imagine is how this came together. But again, the baby steps were practically automated, but it was a matter of, when, okay, great, now we have the diamond appearing on the screen, now it has to make the diamond sound. So that's another thing that needs to be implemented. Okay, now when the diamond is collected, we need to make the end of round sound, because that's a victory. That's a victory. And then we have the situation where we have to show the points on the screen when the thing is collected. And so some of these things are still left to do. You can see that the points when Mr. Do hits an enemy, he gets 500. When Mr. Do collects a dessert, it's supposed to show the point value for the dessert that was collected. And that's not what's happening right now. I'm going to start the game here. So that's not what's happening. If I collect a dessert right now, it just goes away. Mr. Do gets the correct points, but the display of those points isn't it's not showing. So that's the next thing I have to implement that's missing. So there are some things that are missing that I wasn't even sure. I didn't realize that they were missing. It's so concentrated on like getting it right and getting it working and making sure there are no bugs, that that small thing, that what seems small, that was just disregarded by me, which is the fact that when you collect the dessert, it's not showing what points you're supposed to get. And I should also say, yeah, Mr. Do, as he digs, he is absolutely not facing the way the arcade would have him face as he's going down and up. And I think that's okay. That's going to be my little contribution to this game, which is Mr. Do will be the correct orientation as he digs, in the same way that I think any 2D game, modern game would have him move as he's moving up or down. So yeah, that's just a little bit of insight into how this came together. I don't want people to think that this was vibe coded in an afternoon. It was vibe coded, but it was so far from an afternoon of work that yeah, it's many. Oops, I'm opening Prusa Slicer here by accident. It's many hours of time, and a lot of trial and error, a lot of false starts. Some work had to be scrapped because things were broken hopelessly, and the only way back was toss it and practically redo it in the same way you would approach a slot machine and say, like, oh well, I spun the wheel and I lost, I have to spin the wheel again and hopefully it comes out with a better outcome this time. So yeah, that's where we're at. The next thing I need to implement is the high score entry and screen, and I do want to be careful there, because, and it's not that big a deal, but when you're playing a game, you don't really want to and have the game end and be in a situation. Oh, that ended weird, and I'm gonna have to address that. I don't want to be in a situation where the every time the game ends, you're forced to enter a high score to begin to start another game. And because all of the high scores are set at 10,000 as a default, that means anytime you score over 10,000, like the game I just had, I would have to enter my initials to get to back to this screen to start another game. I think that's a step that I would rather people not have to take. So I think I will make this high score a an option you can adjust, so that if you adjust it up to like 50,000, then you need to score 50,000 before you can get your name up on the high score. And but for now I'll leave it at 10,000. But I think in the option screen, which is here, I'm going to add a default high score option, and you could dial that into to whatever is best for your play level. So you have a challenge ahead of you. So that is it. Thank you so much for watching, and we uncovered a bug, so that I'm gonna have to take care of. So thanks again, and yeah, I'll see you next time in another video.